Hello friends, welcome back to the bench. Today we have a pretty interesting case, and for a couple of reasons. This is a guitar amplifier this is the amplifier part, and it comes with the big speaker, big box, right? It is, what is this? I don't know. Maybe it's a good brand, maybe it's not, I have no idea. But what's wrong with it? Actually, I don't know what's wrong with it, or I didn't know what was wrong with it. All I had in the description was that it doesn't work. It happens. So, normally on the amplifiers, the regular speaker amplifiers, I always expect a shorted transistor, blown fuse, because those devices, the user is responsible for connecting the speakers, wiring the speakers, and connecting proper speakers. So usually the faults on those amplifiers are a result of connecting maybe 2-ohm speaker instead of 4-ohm speaker, faulty wire, that kind of stuff, or just faulty speaker. On these amplifiers, on the other hand, the speaker is built into the device, right? So you are only in charge of connecting the input, right? So on these, it's usually the input that's gonna be that's gonna break. But on this one, it's actually pretty interesting, because normally what you expect in any kind of amplifier, you expect a big transformer with center tap, so you have positive and negative voltage, 2 rectifiers, and that goes to the output stage. Here, on the other hand, we have only regular, regular power supply, which that is actually pretty interesting. Take a look at the bridge rectifier. As you can see, only half of the bridge is implemented here, right? We have only 2 out of 4 diodes. So that is kind of interesting, or at least it was interesting to me. I found it interesting. The output is just the regular, what is it, like 20 volts. It doesn't really say over here. And we probably also have 5 volts output. I didn't actually check those voltages over there, because on the board we have 2 voltage regulators. These are 7915 and 7815. So positive and negative 15 volt regulators. So first thing that I did was check our voltages on the output stage. Our output stage in this case is a single chip TDA 2050, and we have non-inverting, inverting inputs, V minus, output V plus. So these are the equivalents over here. Non-inverting, inverting, V minus, V plus, and output. So these 2 are reversed, right? This is this is our V minus, this is our V plus, and our output. Now on our V plus, we have nice 15 volts on the output also. On our V minus, we have -8, right? So V minus is a little low. How do you check it? The the simplest way that I use is using the negative of the capacitor, any capacitor, right? This one's closest, and it so happens that it's test point 21. So that's what I use for ground, and our positive, negative, and our inverting and non-inverting inputs. All seems fine, right? So that -8 being a little lower, because I expected -15, as long as it's negative and it's a little lower or higher, however, depending on how you look at it, but it's a little bit far from what we expect to read on it. But that shouldn't impact anything other than perhaps the sound quality. But this is guitar amplifier, right? It's not like you play music through it. I mean, you literally do play music, right? But I mean, it's not like you're connecting some, you know, music from the computer, or, you know, from the... I mean, you can, but this is monophonic amplifier, so it's not exactly made to be playing regular music. It's made for people to play. Now, I inspected everything with a thermal camera when I turned it on, because yes, first thing that I expected was that our power supply is not going to be producing voltages, right? That's something we can fix. But this is a little bit melted here, but that's fine. But our voltages are okay. Now, as you can see, because I said that I would expect a blown fuse, we have no fuse here. This is completely fuseless. Oh no, this is the fuse. 15 amps. 50, no, 3.15 amps. Yeah, 15 amps seems a bit much. But okay, so we have, yeah, 315, 250. Yeah, I thought this jumper over here was placed here instead of the fuse, but no, the fuse is right over here. The fuse is okay, right? The device turns on. So that's how I know the voltages are a bit low, right? Now there are 3 chips, U3 over here, U2, and where's the marking on this one? U1, right? I cannot find anything about these chips, and on the thermal camera they are getting hot, like 42 degrees hot. So not alarmingly hot, but a little too warm for my taste, especially since these, I don't expect these to be power elements, right? Our only power element that we expect to heat up is our output stage in one chip on the chassis to keep it cool. So we expect this one to heat up, but these, well, I was a little taken back by it. But let's put one screw in so we don't make any shorts and stuff. Right. And let's connect it. I connected obviously through a light bulb because we're working with a switching power supply. Also the oh my god, heatsink on this transistor is not insulated, so there's high voltage on this heatsink. How do I know? Well, the only way, I got electrocuted. Now let's turn it on. It lights up, so it's not exploding. Now we can check the voltages again. Alright, so let's catch the ground over here. And non-inverting, inverting. It's okay that they're close. Negative, which is -8. Positive, which is 36. Well, we are shifted quite a bit from 15. And this is output. Yeah. So we got 15 on the output. This is the speaker plus, speaker minus. 15, 15. So it's also not heating up, right? So it should be fine. So, oops, yeah, this cable keeps popping out because I've been using it for years for testing and fixing power supplies, and it is soldered onto a bulb, so it's kind of hard to replace. Now let's get an oscilloscope. Now, just to be safe, the scope is powered by the battery, it's not connected to the line, right, to any ground. It's completely floating. As I said, that's just to be sure. Don't freak out on it too much, because in the probe configuration you can switch the coupling to AC, which effectively is gonna be the capacitor in series with your load, with whatever you're measuring. So that kind of prevents a lot of faults that you could make. Now let's turn it off first, and I'm gonna connect it to the speaker output. That's why the battery, because there is neither of the speaker outputs, be it positive or negative, should be connected to ground or measured in reference of the ground. Because it's the negative output, it's not the ground. The potential fluctuates in reference to the ground. Now let's turn on, and we had a nice little spike. Now what I'm gonna do is, first I'm gonna use the auxiliary input. Alright, so on this input, come on, get in there. On this input, we're not gonna have a volume control, so this knob is not gonna have any effect because it's auxiliary, right? But first thing that it's gonna tell us, once I connected it, we have nice interference, and as I touch it, yeah, that tells us that we have amplification, right? So the circuit is complete. We have, from the input, we can manipulate output in a way. Now, just to satisfy our curiosity, let's connect it to the phone. Again, the battery powered input, everything battery powered. And let's start the sound, and we see a nice 1 kilohertz wave, right? And as I move the volume potentiometer, nothing happens. So exactly as we expected, but this is auxiliary. Auxiliary might work even when the output stage is not working. because this auxiliary likely doesn't go through output stage. Now let's convert it to a big jack and connect it to the actual input. Before we do that, and this is something that might help you, is first disconnect it from the device, connect it, and measure the voltage. We are on voltage. We got like negative, pretty much nothing, right? And that's what we want to see. Right, I didn't see the meter, but just trust me, there's nothing, no voltage on it. Now, why do we do that? Well, I do that for the same reason as everything, because one time I broke my device by connecting it to the input to the input that had big voltage on it, and I broke my iPod. Yes, that was a long time ago. iPods were a thing back then. Now we are connected to the wave generator and start, and we have a nice wave. Now volume works perfectly. So we have peak to peak 1 volt, and if we go and let's reduce, we go all the way to 10 volts peak to peak. So that is around 40 watts that we can push from it. The output stage is rated for 32 volts. It can be pushed as far as 50 watts. Did I say volts? I meant watts. 32 watts, and it can be pushed to close to 50 watts. So now, what are we gonna tell the owner of this device? As I can't find anything wrong with it, it is working. I will obviously connect. Oh, and actually, sure, let's connect the speaker, because perhaps as soon as you connect the load, the situation might change, right? And I hear nothing when I turn it all the way down, and as you can see, we have a nice flat line. That's what we want to see. So the amplifier is working perfectly. There's nothing wrong with it. There is also a possibility that the speaker is broken, is faulty. So let's check the speaker. And the procedure here is even simpler. We want to see roughly 4 ohms, maybe 8 ohms. Probably not 2 ohms, but it's a possibility. It's an 8 ohm speaker. It's showing 6. Oh, maybe it's 6 ohm speaker. So the speaker is fine. If this was showing either short, right, dead short, that would be shorted speaker. That would explain why it doesn't work. This will probably turn off, and I didn't read actually in the data sheet, but most likely it will turn off if there is oh, there it is. short circuit protection. Yeah. There. That transistor over there, and there's a resistor, and it detects how much current is flowing to the speaker. If it's too much, it turns off. And it's on both sides. So if it was shorted, that would explain why that doesn't work. If the resistance of the speaker is really high, that also happens. Then same thing, it doesn't work, but I don't know, the device just acts like the speaker has not been connected to it. Well, the only thing that I noticed here on visual inspection, because visual inspection gave me nothing, but the only thing I noticed is that the auxiliary in port has been replaced, and the soldering is not too great on it. Yeah. Could have been better, but I don't think that would be an issue. There's also a few other components over here that are not soldered to my liking, not as I would have soldered them. You can really tell from this side, but on the other side there are signs of starvation. And the speaker connector also has been replaced, and the soldering, well, the soldering is not awful, but look at the size of these blobs, right? So also not great, but it's good enough. It's good enough, and it's perhaps, well, it looks like leaded solder, but it's not shiny. So maybe it's lead free, that's why the soldering is so crappy. It's really difficult to solder with lead free solder, and sometimes that is a requirement, and you need to meet that requirement, which makes the job really expensive. No one wants to use a lead free solder. Alrighty, now I'll just put everything back together, give it one more test, and back to the client it goes with a note. Nothing's wrong with it. What's wrong? Probably the cable you used. And interestingly, this has been disassembled before I even got to it, which makes sense because, you know, sometimes it's the easily accessible fuse that blew. So yeah, it makes sense to open it and just see what's inside. But if you're suffering this issue on any device, start with an easy stuff. Check the cable. Make sure your guitar works. Alrighty, hope you guys enjoyed this. Thank you very much for watching, and I shall see you guys in the next one.